divided by -9. That goes away. And I get a equals 3. Oh, isn't that beautiful? All of this work just to do this silly little integral. That's why, like, on your AP exam, it's not going to be this crazy because it takes so long. So it'll be something kind of simple, but or maybe asking you a question about partial fractions, kind of like Newton's method. But we got to go through it. So that's what we're going to do, and that's why I'm not assigning so many problems. So you're welcome, or not, because whatever. All right, let's rewrite this as the blue parts. This, and this, except for when I plug in A, B, and C. In fact, I'm going to probably do that on another page, but A is 3, B is 3, and C is 2. They're all positive. That's nice. So I'll take this integral and I'll change it. I'll write it down here. So the integral will be what is A over x minus 3, and A is 3. So 3 over x minus 3 plus the integral, well, I guess we can do that part later. B over x minus 3 squared, and B is 3. So 3 over x minus 3 quantity squared plus, and I remember it was 2 over 2x plus 3 dx. And now I can split up my integral. I'm going to put the 3 out front, and I have a 1 over x minus 3, easy, plus 3 out front, and I have a 1 over x minus 3 squared, ooh, plus, and I'll put the 2 out front, this 2, and I have 1 over 2x plus 3 dx. This is a dx there as well. So now, I mean, this is the easiest integral. I'll just do that right now. That's going to be 3 times the natural log of the absolute value of x minus 3. But these next ones are a tiny bit different, so I'm going to do them in blue. So I'll circle the plus 3, because I'm going to ignore it, and I'm going to figure out this part. So I will say u equals x minus 3. I'm using u substitution. Du equals dx. Oh, that's nice. So I have the integral of 1 over u squared du, right? Because those are the same, du and dx. And that's just the integral of u to the negative 2. Oh, this is easy. U to the negative 2, I can just use the normal rules for antiderivatives. So I add 1, that would be u to the negative 1. Ooh, divided by 1. So that's really negative, I'm going to put this back down, 1 over x minus 3 to the 1 power now. And I also have to remember that I had that plus 3. So it's actually negative 3 on top there. Hopefully that makes sense. I'm going to erase it and write it a little bit nicer. So it'll be 3 on top, or you can multiply the 1 by the 1/3, like the fraction by the 3. But I think it's cleaner like this. So that's what we get for the middle. And something similar for the side, so I'll try and do that right here. Same thing, u equals, oh, I'll circle the plus 2, because I'm going to forget about it, unless I do that. 2x plus 3 du equals 2 dx. Oh, this is a little bit different. Dx equals 1/2 du. So I get the integral, I'm trying to write it small, the integral of 1 over u times 1/2 du. Okay, so I have 1/2 on the outside, 1 over u du. This one is the natural log of the absolute value of u, but u is 2x plus 3. So that's nice. And I'll put the plus c because that was at the very end. I still have the 1/2, but also the 2. Oh, that's nice. That's very nice. So really, this comes out to be the natural log of 2x plus 3 plus c. And now I'm going to put it all together. I'm going to put it all together over here. And so I get 3 ln of the absolute value of x minus 3. Sweet. And x minus 3, I put the 3 back in. I did that already. So minus 3 over x minus 3, I think it was. Yes. And plus ln of the absolute value of 2x plus 3 and plus c. That wasn't so bad. I mean, it takes so long, but it's if you go slow, use a lot of space so that you're organized. It's not too crazy. Wow, that was a 20-minute video. I gotta cut that down.